So using the first derivative test, first thing we need to find is the derivative. So f prime of x, with that first term, the 3 comes down, multiplies into the 1/3, makes 1. So we have x squared plus 2x minus 3. Now, to find whether this function is increasing, decreasing, and any extrema, those would be maximum or minimum, we need to find where the derivative is equal to 0. So we'll start by setting the derivative equal to 0. And now we have to solve this equation. Well, it's a quadratic. We can factor it. We need two numbers that multiply to -3 and add to 2. That would be 3 and 1. So x plus 3 and x minus 1. Split that. We know either x plus 3 equals 0 or x minus 1 equals 0. So we know that x equals -3 or x equals 1. These 2 points come into play when we go and we find out whether this function is increasing and decreasing. I'm going to start with a number line. We have 2 important points. That's -3 and that's 1. At each of those places, our derivative, which is x squared plus 2x minus 3, each of those places our derivative is 0. Now, to find where the function is increasing, we need to know where the derivative is positive. To find where the function is decreasing, we need to know where the derivative is negative. So what we're doing is a sign analysis. So what I need, along with those 2 points, I need points in each of the 3 areas that we've created. So I'm just going to pick -5, I'm going to pick 0, and I'm going to pick 4. No specific reason for the numbers that I picked, so long as they fit in each of those sections. So now I have to look at my derivative, and I have to see, well, what is my derivative, f prime, when I plug in -5? So I'll do that. It's 12. 12 is a positive number. So I know when I plug in -5, or if I plug in anything on the left of -3, that my derivative is going to be positive. Do the same thing with 0. When I plug in 0, I get out -3 as my answer. So I know when I plug in 0, or anything between -3 and 1, that my function is going to be negative. My derivative is going to be negative, that is. Last but not least, have to plug in 4, see what the sign is going to be there. (21). It's a positive number. So if I plug in anything on the right of 1, 4, 5, 6, 2, 3.7, my derivative is going to be positive. This tells me whether my function is increasing, whether my function is decreasing. So I can say now that this function is increasing on 2 intervals. First one from -infinity to -5. My second one, sorry, not -5, from -infinity to -3. Be careful there. I got caught looking at the -5 that I had plugged in, not the -3 where we have a 0. So it's from -infinity to -3, as well as from 1 up to infinity. Function is decreasing on 1 interval, where this derivative is negative. So from -3 to 1. Both of those intervals are open, because when we have a 0, that means the function's flat. It's not increasing or decreasing. One other thing that I've asked you for, that's the coordinates of any extrema, minimum or maximum. Well, if we look at -3 here, that's when we have the function changing from a positive to a 0 to negative. This would be a maximum. So what I need to do is I need to say I have a maximum at -3 something. Now I don't know the y coordinate of that point until I go and I plug that in to my function. My original function now and by my math I get 10. So the maximum is at negative 3 comma 10. Looking back at my sign analysis, I have at 1 this function changing from negative to 0 to positive. That's a minimum. So we have a minimum at 1 comma something. And again, to figure out what that is, take the 1, substitute it into the function, and I'm running out of space here, so I'm just going to move this over to the left. Now I have a fraction. That's okay, because what's going to happen once we actually get through and we get to the more advanced parts of this unit, we'll actually be talking about graphing these functions. So decimals are going to be okay. All I ask is that you go to at least 2 decimal places. So this minimum is at 1 comma negative 0.67.